What I want you to do is I want you to do example 2 on your own and then come and check it with me. Example number 3. A surveyor wants to determine the width of a lake at 2 points on opposite sides of the lake. She measures distances and angles on the land and then sketches this, not capital D diagram, but lowercase d diagram. How can the surveyor determine the length of hn to the nearest meter? So we're going to look at a few markings here. We're seeing that there's this double line right here. That means that this angle, angle N, is the same thing as angle Q. It's the same measure. And we're saying that angle H is the same as angle P. And another cool thing is that since this J is just one angle right there. So we know that we have H and J is the same, H is the same as P, N is the same as Q, and J is the same as J. So we have two similar triangles. Let me just draw them out. We have this bigger one, which is H, N, and J, and we have a littler one, which is P, Q, and J. So I'm just going to draw in these sketches right here. This one is this one, this one is this one. I'm just going to say J is the same as J, because it's the same letter. Now we know a few things from the diagram here. We know that this one right here is 230 meters, and this right here is 210 meters. And we know that from H to P is 305, and from P to J, peanut butter and jam, or PJs, that's what that also reminds me of. If we add those two things together, we can get this full length. So H, we can just do a little HP plus PJ equals the length of HJ. So this length right here. So let's do it. 305 plus 210 equals HJ. And when I say 305 plus 210, my computer's doing funny things right now. I'm going to say that HJ is 515 meters. So I can write that down. So this one right here is 515. So luckily we have similar sides, or corresponding sides, so that we can create a scale factor. So I need to know what I multiply 210 by to get to 315. So I need to use ratios for that. So I would say that HJ over the corresponding side, which is PJ, if they're similar, which they are, because we know that all the angles are equal, HJ is the same thing as PJ, and P over, oh sorry, my bad, HJ is the same thing as PJ, and then HN over PQ. So if we're able to determine this ratio, we'll be able to use that to do this. So let's just put in the values that we know. So we know that HJ is 515, PG is 210, PQ is 230, and we have HN. Now, let's remind ourselves how to isolate this. What we want to do is we want to multiply both sides by 230, so that the 230s cancel. So we get HN equals 230 times 515 over 210. So that means that HN equals approximately, when you go 230 times 515 divided by 210, 564.0476 meters. So that means since they're the same, or since they're similar triangles, I can say that if this guy right here is 230, I know that this guy right here is going to be 564. So if I were to make a statement here to the nearest meter, I would say that the distance between the 2 points is 564 meters. So in summary, triangles are similar if A, or if one, corresponding angles are all equal, so all three, and two, corresponding sides are proportional. Not proportional, proportional. So what I want you to do is I want you to grab a 7.4 worksheet and work through the paper practice.